All right. So hopefully you got the type 2 error for the test. So a type 2 error is when you fail to reject the null hypothesis when you should have rejected in reality. Okay, so this is blood pressure, and the average blood pressure, time's up. The average blood pressure is 122. We think the people in our company have a blood pressure that's above 122. So mu represents not all people. Mu represents all people in the company. So a lot of times we should define our variable when we're doing a hypothesis test. What is the meaning of mu? So what does mu represent? Mu is all the mean blood pressure of all people in the company. Now they call them campuses. If you work for a large corporation, you go to Silicon Valley. Hey, I recommend San Jose State. It's right in the heart of all of those companies. And San Jose State, you get an internship at one of those companies for a tech company, a tech firm, and you're right there, right? So you can work on a campus. You start out in the restaurant and work your way up. I don't know. I had a friend that did that, so I'm just saying it's possible. If the average is 122 for everyone in the company, we're testing to see if the average blood pressure is above that. And a reason why we would do something like this, stress causes higher blood pressure. So we want to make sure our employees are not stressed. So if we fail to reject, there's not enough evidence that the mean is greater than 122. That's what we'd say. If we reject, we would say there is evidence. And I'll talk about that a little bit more later. But when you reject, you say there is evidence. When you fail to reject, you say there is not enough evidence. So we fail to reject. There's not enough evidence that the mean is above 122. So our company concludes that, or based on this test that we perform, our statistical analysis, we would say, we think that the people in our company have a systolic blood pressure that is not above 122. When in reality, we just had a bad test. Our statistics, our average of 125 is off a little bit. In reality, we should have rejected. We should have concluded that the average blood pressure is above 122. So it doesn't say what are the consequences. That's what we went through in our book, but that's a common question. What are the consequences of making type 2 error? Well, we would say that our company has average blood pressure when in reality, the blood pressure of our employees is above 122. So the consequence would be, it seems that most of our employees are stressed, but we concluded that they're not. Okay. Assume standard deviation of the blood pressure of all employees is 15. So that's population standard deviation. Therefore, we're going to do a z-test. We'll get to z-testing and t-testing next week. Even though I introduced it today, I just wanted you to get familiar with the problem 6 question. There's your standard deviation. N is 100. Mean is 122. What is the sample mean? What is the sample mean? So there's your question. What is X bar? So we kind of have to work backwards with this problem. So if alpha is 0.05, we're going to go to table 3. If alpha is 0.05 and it's a right tail test, this tells us greater than. If we do a right tail test, oh, okay, what happened there? Now my stuff's popping up. It disappeared there for a second. If If we do a right tail test, alpha is 0.05. So upper tail probability of 0.05. What z-score corresponds to that? That is 1.645. So I'm going to plug 1.645 in for z. And you can find that in table 3. You could also find it in the z table. If you just look up 95%, 0.95, you go in reverse or do the inverse of 0.95, and that'll find you a z-score of 1.64 or 1.65. We use the number halfway in between. Or on the calculator is inverse norm 0.95 or inverse norm 0.05. Inverse norm 0.05 will give you the negative z-score. We don't use negatives when we're talking about a z critical value or a t critical value. X bar is what we're trying to find. We're trying to find this one. Mu is 122. Sigma is 15. I'll just draw an arrow right there. N is 100. Now in the problem they said standard deviation of the sample is 1.5. Okay, so we'll get into Z and T testing. If you run into this where you got two standard deviations, the population standard deviation takes precedence over sample standard deviation. If you know population information, then we're going to use it. Okay, so a Z test is more powerful than a T test. T tests have more margin of error. So this is what we're looking for is Z. All right, so I'm going to give you like 2 minutes to solve for X bar. Okay, it's just a work backwards kind of problem. Usually we solve and get a z-score and then a p-value. I think you get like 124.6 or something like that. So I would do standard deviation over the square root of n first and get that number as a decimal. Oops. 124.4675. Cool. That looks good. All right. When you move to C, D, and E, I'm just going to look at these real quick. The actual mean is 125, not the hypothesized value of 122. So they're giving us a new mean. They're saying we could have made a type 2 error because you failed to reject in part A. So we made a type 2 error. That means we failed to reject. Well, the actual mean is 125. In this case, we're making a type 2 error. So they're asking us to calculate this probability. Determine the probability that the null hypothesis will be rejected. Okay. Determine the probability of rejecting the null hypothesis. That is the p-value. Okay, p-value of the test. What statistical term is used for the probability found in part C? Okay, so calculating this probability, they give us a value. The mean is 122, and they're like, but our actual value is 125. Whenever they give us an actual value, a new value. This is called the power of the test. So I talked a little bit about power. We don't necessarily, this is an old test. It's 2018. Calculating the probability of a type 1 error is alpha. The probability of a type 2 error is usually given to us, but the power of the test is 1 minus beta. Let's just look at the solutions. I got them up here, I think. Your sample mean is 124 for your company. The population mean of your company is 125. That p-value is, the z-score is negative 0.35. The p-value of the test is 0.64, and calculate that probability, this new probability, because usually we would have 122 like we did up here. That would be the probability of rejecting the null hypothesis. But now, since we've changed it to 125, it's called the power of the test. Then in part E, they talk about increasing the sample size from 100 to 125. What happens when you increase the sample size? Okay, the denominator of the standard deviation gets bigger. Therefore, that makes the standard deviation overall smaller. So if you have smaller standard deviation, that decreases the spread, and the likelihood of rejecting the null hypothesis would decrease. So you might run into some questions about increasing alpha or increasing the sample size. Decreasing alpha, decrease the sample size. So those are things that we're going to look to in 9.2. When you get into the reading and get into some of the homework prompts, you'll run into those. But I want to talk about proportions. This was about means. So today is all about proportions. So we're going to do a statistical test to determine if the population proportion of all U.S. adults who feel this way, unemployment compensation should be extended. Now this is the problem that we did for confidence intervals. Now we're going to do a hypothesis test. We're going to go through the 4-step process to determine if the population is 40%. So we're looking for the question to determine HO and HA. So what I want you to do is, you could do this with this is just practice. You could do this on AP practice as well. One of the things we want to do in the step 1, which we practiced in 9.1, is write the hypothesis statement in words and symbols. So we're going to write it in words, and they pretty much give it to us right here in where it says number 1. We want to write it in words in context of the question, and we want to write it in symbols, HO and HA. See if you can come up with those. Again, about 2 minutes to do that. Okay, and usually when you write the question, we want a question mark, so we want to phrase it in terms of a question. The ultimate goal with hypothesis testing is to write a question and answer the question. So when we answer the question, we see what it is. A lot of people struggle, most students struggle with answering the question. So that's what we want to do. We want to answer the question. And there's several ways to phrase your question. If there was a more than or a less than, that's when we would phrase it in the question. Do more than 40% of Americans wish to extend unemployment? Or do less than? Okay, so we're looking for those words more than and less than in the problem. We don't have that, so this is going to be an equals and not equals. So we'll write our hypothesis. State the null and alternative hypothesis. Maybe I should do it here. Okay, this is a proportion, so we're going to use P. And here we're going to write it as a proportion because we use proportions in the calculations, in the calculation portion of the statistical test. I don't have a not equal symbol on my computer. Not equal is 0.4. Step 2. I don't have step 2 here, but our conditions are going to be, first we're going to state what kind of test we're going to use. There's all kinds of tests. We could have done a confidence interval for this. That's statistical inference as well. We want evidence. Okay, so we're looking for statistical evidence. In that case, we're going to do a test. So this is called a one sample proportion z-test. In the calculator, it's called a one prop z-test. We'll get to that after we do calculations. And then, was it a simple random sample? Where were the numbers? 1548, 1548 randomly selected adults were asked. One of the more important parts is checking for normality. That's n times p is greater than or equal to 10. N times 1 minus p is greater than or equal to 10. Now when you have proportions, let me just finish this off real quick. Independence. Step 3, we're going to do calculations, including z-score and p-value. Step 4, we're going to do we're going to go to conclusion, and conclusion needs 3 parts. So I'll get to conclusion and talk about that significantly today. 4 is a conclusion. All right, so for normal, n times p, n is 1548. So it's kind of interesting when we do the math. We do 1548 is n, and I wrote it in the simple random sample there. P is 433. 433 people said yes, extend unemployment. I think it ends up being like 29% or something like that. All right, so this is basic math right here. Cancel. And we get 433. Okay. 433 people said yes. So when you're checking this condition for n times p, as long as your number of people, that your x value, your number of people is greater than or equals to 10, could be equals 10. Rarely ever see that happen though. 433 is a big number. A lot of people were in the sample. So it's a qualitative data, so proportion. 433 is greater than or equal to 10. And this is also called your success rate, okay? What number of successes are there? 433. Then your failure is 433 minus 1548 minus 433. That's your number of failures, or the number of people that say no is 1115. Greater than or equal to 10. So that condition for normality is met. So we would write that in words. The condition for a normal distribution, this sample appears to be approximately normally distributed. Independence, 10 times n is less than or equal to the population. So the 10% rule applies here. 10% of the population, well, the population is 1548, which is 15,480. Has to be less than or equal to n. 15480. So that as long as the population is greater than, if you switch this sign around, put the n on the left, put the number on the right, as long as the population is above 15480, then our sample is representative of the population. So population in the US, what are we at now? 400 million or something like that? I don't know. I know we're approaching 40 million Californians right now. Calculations, the z-score calculation. So I'll give you the z-score formula for proportions. We'll do a lot of book stuff tomorrow. I'm just going to use this example today. But in the book, I believe it's page 530. Maybe. The z-score formula for proportions, 553. I was going to say 533. So go to page 553 for the calculation of z-score. And I'll write it down here, and it's good to write it down a few times so it'll sink in a little bit. When you're on the AP test, you always want to write down the formula. You want to state what you're going to use and then write down the formula. Don't use calculator speak, is what they call it. It's like text talk. We don't want to abbreviate. The only time we abbreviate is for SRS. We know that's a simple random sample. So P times 1 minus P. And notice that's a P and not a P hat. In confidence intervals, we use P hat. In testing, we use P. We're testing this population proportion of 40%. I think I had this all set up for find the appropriate critical value. I'll get to that in a minute. So we're going to drop our numbers in there. Oh, by the way, what is p hat? We should list all calculations that you do. Anytime you got numbers and stuff, besides checking for normal and independence, you should put it here in the calculations portion of the problem. P hat was 433 out of 1548. So we're going to calculate that number as a decimal. Use decimals, not percentages, when you're doing calculations. 0.2797. Okay, I'm going with 0.28 for that. So we're comparing 0.28 and 0.4. Is there a difference between those two numbers? It looks like 0.28 is a lot less than 0.4. 0.28 is far below 0.4. Our z-score will measure how far below that number is. Okay, I asked up here, what is the critical value? Okay, so we don't really use critical values too often in testing, especially with this course, but it could pop up. Some courses teach how to reject using rejection regions. And the z critical value we already found when we did confidence intervals. So where do I draw the line? We put 40% in the middle. Your population proportion goes in the middle. Where's your sample mean? Is it far above 40% or is it far below 40%? Okay, this is called a two-sided test. So it's either over here or over here. What number is our cutoff? If alpha is not given, usually we go alpha is 0.05. Which corresponds to a 95% confidence interval. So the upper tail probability is 0.025. The lower tail probability is 0.025. So I got to figure out what z critical value corresponds to that area. So I could do inverse norm 0.025 or inverse norm 0.975. That'll give it to me. I could go to table 3 in my book, table 3 in the back of the book, T3, or it's table B. I could keep calling it table 3. It's on T3. Upper tail probability 0.025. Look at the bottom number, 1.96. Okay, so if I calculate this and I get a z-score above that critical value of 1.96, I'm going to reject. If I get a z-score below negative 1.96, then I'm going to reject. Okay, if 0.4 is in the middle, where is 0.28 at? I'm pretty sure that's less than 40. But is it over here? This is, I call this the fail to reject zone. Anything between those two lines? The cutoff line is the fail to reject area. Well, what we're saying is 0.28 is statistically equal to 0.4. or there's not enough evidence that there's a difference. Okay, over here is the reject region. Over here is the rejection region, reject. So what we want to know is where's 0.28 at. I think the z-score is like -9 or something like that. We got a z-score of -9. I'm going to look up that p-value, and it's not in the book. A z-score of -9. Our book goes up to 3.14 and -3.14 or 3.49. Sorry, I'm thinking of Pi Day. 3.14. We just had our Pi Day. 3.14. Okay, 3.49 is the largest, and -3.49 is the lowest. So our p-value is not in there. So I just know that my p-value is low. The p-value, the smallest number, is 0.001. So I know my p-value just by looking it up. P-value is going, where is it at? It's less than 0.0001 because that z-score is like way out here. It's a really small p-value. In our conclusion, I gave you some information about conclusions last week. There's more. There's a lot to conclusions. Conclusion has 3 parts. We have to make so I'm just going to give you like a template for conclusions. Reject or fail to reject the null hypothesis. Okay, not the claim. A lot of people talk about claims. We don't reject claims, we reject hypothesis, okay? Why did we reject? Well, I just wrote it right over there. The p-value is less than 0.001. And then finally, answer the question. All right, so those are 3 things that we need here. Sounds like a lot of stuff, but we could write it all in 1 sentence. And there's many ways to write your conclusion, but here's a conclusion for this problem. In this problem, the p-value, since p is less than 0.001, which is less than 0.05, do we reject or fail to reject? In this problem, we're going to reject HO. So I answered the first 2 parts of the conclusion with that statement right there. Then we're going to answer the question. Do 40% want to extend unemployment? Okay, so I like to cross off. It's not this one, it's that one. Okay? Do 40% want to extend unemployment? The proportion that want to extend unemployment is not 40%. Sometimes, well, a lot of times we'll use the word, is there evidence or is there not enough evidence? Okay, so if we reject, there's evidence against the null hypothesis in favor of the alternative. If we have evidence. If we fail to reject, there's not enough evidence. So that's an important case. So I'm going to write those things up here. Let me get a cool color. How about St. Patrick's Day colors? All right. If the p-value is less than 0.05, reject HO. P-value is the opposite of that, greater than 0.05. What if it is 0.05? Is you still reject. Fail to reject. And if you reject HO, we have evidence. If you fail to reject HO, there's not enough evidence. Let me get rid of some of this other stuff over here. All right, there we go. I can bring it back if you want me to. So I have, that's part of your rejection decision. And we would use it in words. We would say if we reject HO, there's evidence to reject the null hypothesis. Or we would say there's not enough evidence to reject the null hypothesis. There's not enough evidence that there is a difference. Okay, I like to use the words difference or no difference because sometimes when you reject and you have a two-sided test, or if you fail to reject, you say there's not enough evidence that the proportion is not 40%. And I call that a double negative. You use the word not. Well, that's kind of like saying there is evidence that the mean or the proportion is 40%. Okay, so we try to avoid that situation by using the word difference or no difference. In HO, that means that there's no difference between the sample mean or sample proportion and population proportion. If we fail to reject, we're saying there's no difference. Okay, that's the fail to reject zone. That's why I like the picture of the normal distribution curve. If there is a difference, that's in the rejection zone. That means there is evidence. Okay, so that helps paint the picture of what we're doing with this. All right. So in your conclusion, multiple ways to write it. They kind of give us a little template of writing conclusions. There's an example on page 553 that I encourage you to read through to get an idea of how to write conclusions. 9.1, chapter 9, section 1 goes into it a little bit, talking about writing conclusions, but we're really establishing how to write conclusions here in 9.2. So these are kind of notes right there. How about this z-score of -9? We didn't know what the p-value was. The only real way to find that on the calculation is to do a test on our calculator. So let's get into the calculator. Let's do a one prop z test on the calculator. So when you go to stat, go to test, you'll see z-test. Okay, this is z-test, but it's not a z-test for means. Z and t-tests are for means. Okay, we weren't given a mean, we were given a proportion. So we have to go to one prop z-test. There's two sample stuff, two sample z-tests, two sample t-tests, two prop z-tests. We'll get into two sample stuff in the next chapter, chapter 10. So chapter 10 really reinforces everything that we're learning here in chapter 9. So one prop z-test, we only have a few pieces of information that we need for a one prop z-test. So I encourage everyone to get the calculator. P0, that's your population proportion. We use 0.4. X is 433. 433 people said yes. N, 600. And prop. Are we going to choose less than, greater than, or not equals? Okay, so in this problem, we're testing not equals. Okay, so we're going to choose not equal. So I got a z-score of negative 9.6. The p-value is 4.5 e negative 22. That's really small. And that takes into consideration when you do a two-tailed test, you find your p-value, you can look it up or do inverse norm or Normalcdf, sorry. And then find your p-value, you got to multiply it by 2. Okay, so we'll talk more about that tomorrow, about finding the p-value, but the calculator does it for us. P-value is low, reject the HO. Okay, it's a really low p-value. The p-value, really important, is not 4.5. It's a decimal. A lot of people will say, oh, the p-value, 1.2 or 6.3. P-values are always probabilities. They're numbers less than 1. You can't have a probability of more than 1. No, I did. Oh, and I said 1548 and I wrote 600. Good catch right there. Sorry about that. This is a wrong number. I put 1548 in my calculator. Why did I say 600? 1548 was the sample size. Yeah, and it's 1548. I'm not sure why I did that. All right, so we see that p-value. All right, this is testing if it's equals and not equals. Well, I'm going to go take this one step further. I think that 28% actually is less than 40%, right? So let's test if we would have to go through the whole statistical test again, but we would have to write our hypothesis statement again. We already did the conditions. We don't have to go through the conditions again because the conditions would all be the same. But our calculations, if we do our calculations, we would still get the same z-score because 0.28 doesn't change. We're testing if negative 9 is below 0. Okay, I'm pretty sure it is, right? So if we go back and we change our z test, one prop z test, change it from a not equals to a less than, and calculate, we get the same z-score. We get a p-value of 0. Okay, the p-value is really, really small if we do a left tail test. If we do a less than test, if you do get a greater than test, is 0.28 greater than 40%. Then you get a really high p-value. You get it like 99% chance that 0.28 is greater than 40%. Okay, that's not evidence that there is evidence that 0.28 is greater. We know that 0.28 is actually less than 40%. All right, I'm going to clear all this goodies. Let me use my eraser because I want to keep some things on here. All right. So we got our notes there, and this is for your conclusion. So what I want to do right now is look at a right tail test on page 553. Page 553, go through the example 1 potato, 2 potato. And I want you to read it. I'm going to give you like 10 minutes to read through it, and then we'll talk about it. On page 553, we're talking about a left tail, right tail, and two tail test. So you see the greater than, the less than, the not equals. Okay, so that determines what kind of test you're doing. In this problem, it says P, the proportion of potatoes that have a defect, is 0.08. Either 8% of the potatoes have a defect, or if more than 8% of potatoes have a defect, we're going to send the truck back. A truck full of potatoes. Have you ever seen a truck full of potatoes? I see tomatoes, I see cauliflower, broccoli, but not tomatoes usually. So 0.08 is right here in the middle. So this is Z, in terms of Z scores, 0.08 would be right here. What if you got 0.081? What if 8.1% of your truckloads have blemishes? Okay? That's no different than 8%. What if 8.5%? Is that different than 8? Not really. Okay, so where do we draw the line? Our cutoff line. I call it the cutoff line. Don't cross that line. If you do, that's your cutoff line. What Z critical value is that? That corresponds to an alpha of 0.05, not 1.96. In this case, we're doing a one-tail test. We're finding the probability that our proportion lands over here. So this number is actually 1.645. Let me double check. Table 3, T3, table B. Upper tail probability is 0.05. Look at the bottom of the table. You get 1.645. So we're going to calculate Z-score. So in our calculation, we can do our Z-score calculation. 0.08 is our population proportion. Our sample proportion, 47 out of 500 potatoes have blemishes, which is 0.09. 0.094. About 9.5% of potatoes have blemishes. Is that greater than 0.08? So that Z-score comes out to be 1.15. 1.15 is right about here. Here's 1.645. 1.15 is right about here. That's in the fail to reject zone. 0.095 is not different than 0.08. There's no difference. So sometimes in the HO, I guess I left off HO and HA. In HO, there's no difference. We don't want to say that 0.09 is equals to 0.08 because that's not true. But we could say there's no difference between the two proportions. And in our conclusion, we would say there's not enough evidence that the proportion is greater than 0.08. So 0.09, there's not enough evidence that in our sample we have more than 8% blemishes on our potatoes. P-value. P-value is low, reject HO. So the p-value is 0.1251. And there's a picture of it where you could draw the picture on your calculator. We'll do both. 0.1251. So that's your p-value. Again, going to that conclusion, we could use Normalcdf to come up with the p-value. We could look it up in the table to get the p-value, or we could use the calculator to get the p-value. So I'm going to calculate it. There's two ways to do it on Normalcdf. So I could do it in terms of the original values. I want to know what's the area to the right of 0.094. And we use a big number like 100% of the area, and then the average proportion is 0.08, and the standard deviation for the proportion, I didn't calculate it. They didn't calculate it either. I gotta get it 0.08. .012. Or we could write it in terms of z-score. This is getting that 0.1251. The z-score was 1.15. We need to use a big z-score because I'm going to the area to the right of 1.15, like the picture shows, page 554. The z-score is 0, and the standard deviation of z-scores is 1. So they both should give us 0.1251. Let me do that on a calculator. Second vars. Well, 12507. Okay. 07. 4 decimal places. How do you get it in the table? If you look up 1.15 in the z table, it's the z-score. The left tail area is 0.8749. That'll give us this area over here. This area to the left is 0.8749. The area to the right of that line is 0.1251. So that's where the 1 minus 0.8749 comes from. Okay? The table gives us left tail areas, but we want a right tail area because this is a right tail test, or the area above 1.15. I noticed that my video on chapter 2 has 63 views. That's cool. It's about that many people in our class, so people are going back to chapter 2 and looking up this normal distribution stuff. Nice. Calculator. Calculator is called a one prop Z test. And we're going to enter our information. So let's check it on the calculator. And we always use the calculator to double check if we did it right. P sub 0.08. X was 40. Was it 40 potatoes? 47 of the potatoes have blemishes. So X is 47. N was 500. Not equals, less than, greater than. I'm going to do the draw this time. Let's draw it. So the draw will give you the picture that's on page. Dimension mismatch. Okay. What did I do wrong? I think I got to turn my plots off. There we go. So I got my z-score 1.15, my p-value 0.124, sample proportion 0.094. But I wanted to draw. I'm going to go to one prop z test and draw it. You have to turn your plots off if you want to draw it. It's going to draw a normal curve, and it shades the area under the curve. It gives us the z-score 1.15. It gives us the p-value 1243. Notice that there's two different p-values. There's 0.1251 or 0.1243. The calculator gives 0.1243. I would just use 0.1251. If you write down a different p-value than your z-score calculates, then you'll probably get lose some points for that. What if you accidentally chose less than? If you chose less than on your test, you would get 0.8749. That would be the left tail area. That would be the probability that 0.09 is less than 0.08. Okay. Your p-value. So interpreting the p-value. All right. Questions so far? I know it's all new for you guys. The best thing